This is Neseba on the Black Sea coast in southern Bulgaria, an area which has seen a huge increase in the demand for tourism in recent years. Transport links are improving, prices are still quite low, and as this demand for tourism has increased, so has the demand for hotels and apartments to meet that demand. And there are people here who are responding to that need by investing in new hotels and so on. Is the cost per room, does it get smaller if the hotel is bigger?
Ако имам 3-4 етажа нагоре, много.
But there comes a point where it's very difficult to go any higher because the foundations aren't strong enough. If you're a developer and you're trying to make a profit, you have to think about how to control the costs of construction. What happens to construction costs as you increase the number of floors you build? Well, clearly the answer is the more floors you build, the greater the cost. But what we're interested in is the speed at which those costs rise as you add to the number of floors. You might think the more floors, the lower the average cost. There are economies of scale to be made. But the problem is that beyond some point, if you add even more floors, you have to dig deeper foundations, you have to use different materials because of the problems of winds with tall buildings. So costs rise relatively slowly at first as you add more floors, but relatively rapidly beyond a certain number of floors. So how many floors would minimize the cost per floor? How many floors minimize average costs? The costs of building the hotel have been estimated as follows. We'll have X as the number of floors, and all values will be in euros. The only fixed costs are associated with the land purchase of 100,000 euros, and the variable costs are as follows. We have 40,000 euros per floor plus 500x euros per floor, reflecting the added costs associated with deeper foundations, different materials and so on as we make the building taller. So now let's establish the average total cost curve. Total costs are 100,000 plus 40,000x plus 500x squared. So average costs are simply the total costs divided by the number of floors divided by x, which gives us 100,000 over x plus 40,000 plus 500x. Or more usefully, 100,000x to the minus 1 plus 40,000 plus 500x. Now we want to find the minimum average total cost, so we differentiate the average cost curve and set it to 0. So the derivative of the average cost curve is minus 100,000x to the minus 2 plus 500, which equals minus 100,000 over x squared plus 500. So we need to solve minus 100,000 over x squared plus 500 equals 0. So 500x squared equals 100,000. Then x squared equals 100,000 over 500, which solves at either plus or minus 200. So x is either 14.14 or minus 14.14. Well, in this context, of course, the minus number is meaningless, so we've established that given our estimate of the cost function, the minimum average cost
will occur if we construct 14.14 floors.